Good afternoon. I hope you're having a good Thursday. As I told you yesterday, I'm not here today. My husband's having surgery, so we're going to do a video lesson. First, we're going to look at the warm-up. You should be able to look at it and figure this one out. I think it's an ACT question. So pause it for a second, see what you think the answer is. Okay, so if we have 4 times the sine of 2x, remember this 4 is the amplitude of the wave. So if we're talking about a sine wave, it's going to go up to 4 and down to 4 based on that amplitude. The 2x basically just says that it is being, works opposite, so it's being shrunk in the horizontal direction. So that doesn't really affect the greatest possible value. So a normal sine wave has a value of 1. So since this has an amplitude of 4, it would have the greatest possible value would be a 4. So the answer would be C. Flip pages. Okay, there we go. So today we're going to work on graphing in polar coordinates and what polar coordinates mean, and then being able, if I have a point, figure out what the coordinates of that would be. So you've been graphing in what we call Cartesian coordinates, or like we say that this point might be x is 3 and y is 2, right? Those are Cartesian coordinates, they're xy plane. So we're going to talk about a polar coordinate. So first I want you to, it doesn't want to do it that way. Let's go back to this way. Look at this picture. So you might recognize it has an aircraft over in the corner. You might recognize this has to do with traffic control for airplanes. So if you think about what do they care the most about, right? These traffic control places are at airports. What they care the most about is how far the plane is from the airport, because they have all kinds of planes coming in from different directions, coming into the airport to land or leaving the airport to take off, right? So they don't care so much about an x and a y coordinate, right? What they really care about is what is the distance from the airport? How far away is that plane? So that's really, this kind of thing is really what we're talking about when we're talking about polar coordinates and the people who kind of care about polar coordinates, because it gives you a distance from the center point. So polar coordinate system is just another way to plot points on a plane that's different from the rectangular coordinate system. So instead of using x and y, let me scroll this down a little bit. Instead of using x and y, it's going to use the distance from the origin. I guess I should go over here. The distance from the origin and the angle that the point is at. So we're going to talk about a distance and an angle ties into our unit circle instead of a rectangular. Now, what's kind of interesting is that if I take this polar coordinate, oh, it's not going to let me slide that over there. The polar coordinates are not separate from the rectangular. It's just a way of measuring the same point on a different grid. So just like if you were in Desmos, you can go to the graphs and hit polar and it'll change to this kind of a coordinate system. The point doesn't move, just how you measure it moves. So if I was going to draw these little circles, these circles here are constant radii. So this is everything that is 1 from the origin. I could put that on the rectangular system. And then I could put a circle that is 2 away. And I could put a circle that is 3 away. And I could put a circle that is 4 away. So the rectangular system behind here and the polar system aren't in 2 separate universes as such. They exist together. They're just different ways of measuring. So if I have a point, pick a different color here. Why won't that do what I want it to do? just doesn't like me at all. So let's try that. There we go. So if I put a point right here, I could measure that point as being 1, 2, 3 in the x direction and 1, 2, 3 in the y direction. Oops, I wanted to put x there. It could be the 0.33. Or we can look at that point and say this point is this distance from the origin at this angle. So we're talking about the same coordinate systems. It's just that we're measuring in a different way. So polar coordinates come in r theta. One of the things that is, I guess, a little bit different is your radius is going to come first, is the first number, and your theta is the second number. So if I wanted to, I want that to scroll a little bit. If I wanted to plot the point 445, so a radius of 4 and at 45 degrees. So each one of these circles, so that's right there is 0. And this second circle here is 1. This second circle is 2. The third circle is 3. The fourth circle is 4. The point 445 is right here. It's on the fourth circle from the origin, so that means it's out 4, and it's on the 45-degree line. So that would be that red point that's right there. If we look at the second point, which is the blue line, the blue dot, we have to be on the 6th circle from the center, and we were going to be at 120 degrees. So 120 degrees is over here. So we have 1, 2, 3, 4, 5, 6. So our blue point is at 6, 120. Our green point is at 2 pi over 6. So if you remember from your unit circle, pi over 6 is the same as 30 degrees. So we're going to go out 1, 2. So we're going to go to the second circle out. Radius is 2 at pi over 6 radians. And the last one, our purple one, the radius is 3 and the angle is 3 pi over 2. So 3 pi over 2 is straight down. So the radius is 1, 2, 3. So that would be a point that's right here. So this part is all fairly straightforward. So let's move on to the next thought. So you can write polar coordinates in multiple ways. There's not just one way. It's not just it's always r and theta, but you can use positive r's, you can use negative r's, you can use positive thetas, you can use negative thetas. So we're going to look at what would it look like to write the same coordinates of the same exact point in 4 different ways. So we're going to start with the basic one, positive r and positive theta. So if I do a positive r and positive theta, if I look at this, it's out 1, 2, 3, 4, 5. So your coordinates are still in parentheses, just like xy coordinates. So our radius is 5, and our angle is 330 degrees. If we go down, let's go all the way down to C first, with a negative theta. So we're going to do a positive radius and a negative theta. So positive radius, it's still going to be, it's 5. But instead of measuring the angle in the positive direction, we're going to measure the angle in the negative direction. So in this direction, the angle would be negative 30 degrees. So we have 5 negative, whoops, I put that in the wrong spot, sorry. Erase. Try that again. It's 5 negative 30 degrees. Okay, now the next part's a little trickier because it's a negative radius. So if you think about, if I'm starting at the origin and I'm facing this dot, moving toward the dot is the angle that gives you a positive radius because you're moving from the center out. if I want to think about this as going the other way, I can think about looking at this as my radius is at the 150 degree direction. I'm going at the 150 degree direction, but I'm walking backwards. So if you picture yourself here facing 150 degrees, so my angle is 150 degrees because I'm facing 150, but I'm going to walk backwards. I'm going to walk backwards 1, 2, 3, 4, 5. So -5, 150 degrees is the same as 5, 330 degrees. Okay, so when you think about using a negative radius, think about you're going to face away from the point. So instead of looking at the 550, the 550. Instead of looking at the 330 degrees, I'm going to look the other way, but I'm going to walk backwards. Okay, the last one is with negative radius and a negative theta. So because I'm going a negative radius, I have to be looking away from the point. So I'm still going to be looking, here's my point, and I need to look away from it. So I'm looking this way, just like before. So my radius is going to be -5 because I'm looking away from the point. But instead of measuring the angle this way to get to 150, we're going to measure the angle from the negative direction. So the red arrow shows you a -210. So it's going to be a -5, -210 degrees. Or I could put these in radians. Zoom this out a little bit so you can see better. Okay, so a couple other points to play with. So if we look at 5, -120, we'll do this one in red. So I'm going in the -1, the radius is positive. I'm going to go to the -120 degrees. So that's -90. So -120 is going to be this angle right here. So I'm going to face that direction. And I need to go out 5 units. So I'm going to be facing the -120 degrees, and I'm going to go out 5 units. So I'm going to go 1, 2, 3, 4, 5. Even though I want that to be red. 1, 2, 3, 4, 5. There we go. If we look at the 5 -pi/4, same thing. I want to go -pi/4 in the -pi/4 angle. The radius is positive, so I'm going to face that angle. I'm going to go that way toward the -45 degree angle, and I'm going to go out 5 units. So 1, 2, 3, 4, 5. So if we go to the next one, -2, 3π/4. So 3π/4, there's 1π/4, 2π/4, 3π/4. So we're facing 3π/4, but we are going to walk backwards because the radius is -2. So let me get the old blue arrow off of there. So I'm facing the green angle, but I'm going to walk backwards 2 units. So that means I'm going to go, not with the eraser. Pen, please. There we go. So 1, 2, I'm walking backwards. So I'm going to end up right here. Okay, I'm going to have to stop this. I only get 15 minutes of time, so I'll put the second one on momentarily. You'll just have to switch videos.